This is my game from Global Game Jam 2023. Just play it. Oh, Jesus. All right, so what do we have on the screen here? So I'm a kind of parsnip cowboy wielding a gun shaped like a square root symbol. And I can shoot these bullets at the Saxon horde that is chasing me. And you can see maybe at the top left it says hit when the bullet hits the Saxon. And that's basically it. That's the game. If I run far enough away, they actually will stop chasing me. Yeah, so the theme from this year was roots, and so that's why you're a parsnip, a root vegetable, and you're wielding a square root. It was going to be like kind of a punny game involving math, where you like shoot numbers at things with other numbers on them, and then using like square roots and stuff, you're damaging them in an interesting mathematical way. But got really burnt out and just didn't finish it, which is fine. I did make some cool stuff, which I'm pretty proud of. I made this with a couple friends of mine. One of them worked on some of the art, just the character art with the character and the gun, and then the other one did some of the logic around the shooting, and I did like the character programming. So one interesting thing about this game is that it is actually fully 3D. It looks like a 2D game, but it's not. The graphics are 2D. So this is something I'd heard a while ago. I think I talked about this actually in a previous Game Jam video, that if you're making a 2D game, still make it 3D, just make the graphics 2D, because doing stuff in 3D is nice. So I was curious about that, so I tried it out with this one. And yeah, there's a lot of interesting stuff. So you can see like everything is just billboarded, so all the like obstacles and stuff in the stage always face you. A character always faces you, no matter which way you're going, just using billboard, which is thankfully a built-in thing in Unreal Engine. So what's the interesting stuff about this? Well, so for one, there's this interesting aspect of like, you know, things, if you program them right, you get like really interesting automatic behavior. Like, let me actually modify here. I'm gonna get rid of all these guys just so that they stop harassing me, and we can like kind of play around with them. And here, I'll just make him uncontrolled. So like if I just go in and take this guy here and I actually just like modify his rotation, you can see like I'm modifying his actual like actor's rotation in the world, and he like automatically spins around to face the right direction. So in that sense, it is like not really like much trickery. There's still a lot of trickery going on, of course, but it's like kind of interesting because you can get this free behavior where it's like when something just moves by any means, the screen does update to reflect, you know, approximately what it should look like, even though it's using 2D sprites. So I kind of designed it in a way where it's like you could even potentially have like cool cinematic camera movements where the camera's like rotating and like swooping through the scene, and everything would still look pretty much correct. I would need to update the programming a little bit to handle that, but yeah, that's the basic idea. And like also this fact, like, so it's fully 360-degree shooting. Like I can shoot in literally any direction. It's not like locked to, you know, a discrete number of axes. And so you get this like cool behavior for free where like you can see the gun is actually like smoothly tracking the mouse as I spin around, even though it still snaps to the 4 directions that we have sprites for. And that actually comes for free as well, because the character model is actually the 2 sprites, like the character and the gun, and they're actually just holding the gun out in front of them. So again, we're just saying like the character is smoothly rotating to track the mouse. Like if I were to modify, how do I find this? Let's see, it would be on their capsule. There we go. So you can see now, let me click away. you can see their the mesh of their capsule. You can see it's actually smoothly rotating to track the mouse at all times. But it just looks 2D because we're using these billboarded 2D sprites. And so you are getting this like nice smooth 3D game behavior where you can have like, near misses with things and stuff. It really is a 2.5D game, I guess. Really more on the 3D side than 2.5D. It's literally just the sprites that's 2D. So I think that's kind of cool. You get free behavior like that. Also things like where the gun kind of goes behind the character, and things where it's like, oh, if I walk behind these cactuses, these are drawn in front of me. All of that's using like normal 3D rendering techniques. So you don't have to do anything fancy about like sorting your sprites so that they draw in the right order. So this project kind of convinced me of this, game design wisdom I'd heard about, like, just do it in 3D. You get a lot of cool behavior. It was my first time using Unreal Engine, so that was definitely a challenge. Part of the reason why I got kind of burnt out and didn't feel like finishing the game, but whatever. And there were some gotchas there. So initially I was thinking, oh, I'm doing this like 2D billboard art style. Let's use an orthographic camera. That was a bad idea. Orthographic cameras are like super buggy in Unreal, and we had this annoying bug the whole time where if I like walked up, all the sprites would turn black, and it was just really stupid. But I finally just switched. So this is just like a normal perspective camera, just with like a very narrow field of view, which is close to orthographic, and that works fine, as you can see. It gives you like a tiny little bit of perspective where things get bigger and smaller, which actually sort of works. So I should have just figured that out sooner. So I can talk about some of the technical details here. Let's talk about maybe the materials system. So one thing that I did, I don't know if this is good or bad, but I think it's interesting, is Unreal has its own 2D animation system called Paper 2D, and I didn't use that because I didn't know anything about it. And I only knew about traditional 3D materials, but I felt like I could make it work. So how I achieved this effect, where like you get these 8-directional sprites, is just in these materials files. So starting off, very simple. Let me make this flat so you can actually see them. So starting off, I just load this texture sample, and this is a sprite sheet, as you can kind of see from the preview here. I can just pull it up. Yeah, so it's a sprite sheet it's a 5-directional sprite. You're supposed to mirror it. I didn't feel like doing the math of mirroring it in an engine, so I literally just mirrored the sprite sheet so that I didn't have to do that math. And then I load that, hook it up to the RGBAs. One minor trick there, you have to make sure that the compression settings for the texture are right, so it's not dropping the alpha channel, otherwise it looks weird. But anyway, and also doing nearest neighbor filtering, so you get nice pixel art. Then here's the trick, is you use this flipbook component that's built in, and this basically can cut up the sprite sheet for you and then let you select a single frame, and you use that as the UVs. So that's how you get just a single, I'm not displaying the whole sprite sheet, I'm just displaying a single sprite. And then all the math and all the trickery is in how you select this animation phase. So that's what this stuff is over here. So first, just to make it a little more understandable, I made like the rows and columns variables so that I could reuse them. Because the annoying thing is, like, it's this animation phase 0 to 1. I find that very unnatural. I wanted it to be actually indexed, like where it's like sprite 0, sprite 1, sprite 2, sprite 3 in the sheet. So this bit here, this multiply divide, is just a very simple math to make it so that if I have like, here, let's put it this way. There we go. Thank you for reloading. So now if I'm controlling this input, I can just very simply select different sprites in the sheet just by a number, which I find much more convenient to think about. Like, there we go. So that's all that's doing. This part's actually not that crazy. The crazy part is then having logic to select a particular sprite at the right time. So what I did is I added 2 parameters to this guy, which is what direction he's facing in angle, in like the degree angle, and then a frame number. This sprite is kind of particular where he has, you can see he just has like doesn't have an idle animation. He's just like, this is his standing still, and then he has 4 frames of walking. And so for this one, it's kind of like a little simplistic, whatever. It doesn't matter. You can select like 0 through 4. 0 would be idle, and then 1 through 4 is walking. That's the idea with that frame number. So if I go in here, you can see 0 is, so he's facing, 0 is pointing away from the camera. So then if I do 1, 2, 3, 4, that's his walk animation pointing away from the camera. But then I can do things like, I can set this to 90, and then I can do the same thing. So idle, and then the walking animation. And so I won't go into the details here because it's not interesting, but basically you kind of segment up the circle in degrees. And so this is just doing some math to like, dividing it into 45-degree chunks, because this is an 8-directional facing sprite. Doing some modulo, a little bit of hackery with the coordinates because the sprite sheet is ordered in an inconvenient way. And then, doing some like row and column shifts using those values. And that's basically the idea. And so then all you need to do then, once you have this sheet, is you need to hook up some logic to your pawn to every frame input its rotational angle around the z-axis, and then if it's doing some like movement, it can input the frame number. If it's not moving, it can input 0 for this one. And that's exactly what we have if we go to the Saxon. Actually, let's look at the other one. So the player is doing the same thing. So I'll just prove that to you real quick. So the player material, doing a similar kind of thing as facing and frame number. Difference here is that this sprite has a walking animation, so and an idle animation. So you actually need a third input to say like, are we running the idle animation or running the walking animation right now? So like this one here, let me just do this. So if I do like frame 1, 2, 3, 4, 5, 6, 7, and they're also different lengths. So you can see that's his like little idle animation running there. But then if I change that to walking, not 0.1, then now it's his walking animation. And that's only 4 frames, so 0, 1, 2, 3, and then 4 is blank. So you can have different animations of different lengths using this system. You just have to kind of hack it a little bit. So the idea is for each sprite sheet you have to make a different material, and the material sort of encodes the positions of the different animations in the sprite sheet. That's the idea. So then if I go to this guy's event graph, it looks simple, but that's just because I pulled it into functions. So every frame he has to update the billboard facing so that it like reflects the position in the world, and then also run any animations that are occurring. So the billboard facing is actually not too bad. You get their rotation. We just want it around the z-axis. Again, that's all that matters for the sprites we have. And then you set that into the facing parameter for each material. So here we have the gun material, and here we have the player material, and we just set this facing parameter for both of them. This is where that one simplification comes in that I mentioned, where you could do something with like cinematic camera movements. You would have to update this to also as input, not just the actor rotation. You'd have to get the camera position and then do the relative rotation from the direction the camera is looking, right? That would totally work. I didn't feel like doing that, so I just conveniently set up the camera so that everything, you don't have to do that. The actor relative position to the camera is the same as the actor's world position. That's just the easiest way to set it up so that it works without any extra effort. But there's like just a couple places in the code that are making that assumption you would have to update. So that's that one. And then if I go to this walk run animation, so this is where we're taking in the delta time because this is like, you have to like compute the delay so that you're like animating the frames at the right rate. I guess a side note here, this was really annoying. I was really hoping that Unreal had some convenient like animation system like Unity does. Like Unity basically has arbitrary animations to do whatever you want. You can make an animation that, controls the parameters on literally anything in the engine, which is probably one of the coolest things about Unity. And then you can attach that animation to various objects and do whatever you want. Unreal does not seem to have that. I couldn't find it anywhere. Basically, Unreal only has skeletal animations if you're doing 3D modeling, and then it has things called sequences, which are more for like, if you want like a cutscene in a level. So a sequence is attached to a level, and it can animate anything about that level, but it's not attached to something like a pawn or an actor, which is really annoying because like that's what I wanted here. I wanted it that you spawn this actor anywhere in any level and it'll have this behavior built in. So I couldn't find a way to do that other than just programming it. So this is a huge mess, but I did get it to work. So you go in here and it's like this rat's nest of visual scripting, which really isn't that great. Some visual scripting stuff is wonderful. It's so simple and you're like, oh, I get it. This part, I just wrote this in actual code, like pseudocode to think through it, and then I manually translate it to visual scripting because it was so hard to think about. But the general idea is you store their previous velocity in a variable so that you can tell when they go from like not moving to starting moving or vice versa, because that's where you need to switch from one animation mode to the other. So you get their current velocity, you get their previous velocity, you see if they switched from one to the other. So that's what these are. It's like, did you start moving? Did you stop moving? You have two ifs about that. We use that to set a Boolean variable, which is, are you walking or not? You also update that parameter in the texture to tell the texture whether they're walking. You reset it to the first frame of that animation because you just started walking. So we're starting on the first frame of the walk or the first frame of the idle. Then we also update the frame number. We have to store it in both. We have to store it in the in the program here in their script because we need to remember that later when we're iterating to the next frame of the animation. And then we set it in the texture because the texture is actually doing the drawing. And then we also reset the time until the next frame to, we have this frame interval, which is just like, there's a static interval of how long the delay is between each frame. This would be much more complicated if you want to do like variable animations where you're like holding on certain frames. Like this is where I had to simplify a lot. Like ideally, again, you would have like more of a timeline system to let you easily do arbitrary things like that. And here, because you're programming it, it's a pain in the ass. So I just did the simplest thing where there's like, I think a 1/4 second delay between every frame for every animation. And then last but not least, you update the previous velocity to the velocity we started with. So that's that path. And then if they didn't switch animations, then there's the whole logic about, okay, we're just continuing the current animation. So we subtract the delta time, we see if that dropped us below 0. We have this time until next frame. We subtract the delta time from that to see like, okay, did that drop below 0? Then it's time to advance to the next frame. So if we're not advancing to the next frame, that's this false branch, so we're done. We don't have anything else to do. Oh, I just realized that's wrong, actually. If we're not advancing to the next frame, we should still update the velocity. So I'll fix that right now. This is one of the things where visual scripting utterly sucks. Like, this algorithm here is like, I want to like do all these different paths, and then I want to make sure always at the end of it that I'm updating the previous velocity, because that's important to make the calculation correct. It's actually really hard to see that in a visual scripting language. It's trivial to see in a program because you can just see like, okay, and then at the end of the function, I call this thing always. Pretty easy, but anyway. So if it is time to switch to a new animation frame, then you just do a little math. This is a trick to, so this part is particular to how that sprite sheet is arranged. This is basically, or rather, it's particular to the lengths of the animation. I know that the idle animation is 8 frames and the walking animation is 4 frames. So this part is just like going to the next animation frame, and this part here is accounting for the fact that the animations are different lengths depending on what the character is doing. This would also be really painful if the character had like, 10 different states they could be in. Again, like Unreal Engine has this cool animation system where you can have state machines and transitioning between different states, but it only works with frickin' character meshes. Maybe there's a way if you used Paper 2D, but again, I didn't use any of that, so maybe all of this would be a million times easier in Paper 2D. I have no idea. Anyway, all that said and done, now you can set the frame and then the animation is done. Beautiful. And I think that's basically it. Yeah, that's their whole event graph. Construction strip. Oh yeah, this part is like, whenever you're doing these dynamic textures, this is probably the most annoying part to hook up. It's easy to do this wrong. Since you're doing dynamic textures, you have to make sure you're not just like selecting the material in the editor somewhere. You have to have a construction script that creates dynamic materials and that you're saving those in variables you can use later. Other horrible thing about scripting is I wanted to have like an initializer that sets all the default values, and this looks like this is so hard to read. I wish it was just like you could like list out here are all the default values. Maybe there's a way to do that that I missed. I don't know. But yeah, that's basically it for all the interesting stuff, I think. And yep, that's the game for this year.